Might you at any point believe it? Picture a heavenly event so massive that it casts shadows on Earth visible even in broad daylight. That is the spectacle we may be on the verge of witnessing. In the Orion constellation, the star Betelgeuse is behaving strangely, possibly signaling an impending cosmic explosion that will illuminate our sky like never before. But when will Betelgeuse go supernova? And what will it look like? According to researchers, what secrets could this celestial event uncover? Join us as we dive deep into the mysteries surrounding Betelgeuse and the impact its explosion could have on Earth and perhaps the entire solar system. A red supergiant on the brink of explosion. Located approximately 650 light-years from Earth, Betelgeuse is not just any ordinary star. It is a red supergiant, one of the most luminous stars known to us, shining with a brilliance over 100,000 times that of our Sun. Betelgeuse stands out not only for its brilliance but also for its historical and cultural significance. Its name originates from the Arabic phrase Yad al-Jaws, meaning the hand of Orion. Ancient civilizations have observed and documented this star for centuries. It has been a guide for travelers and a source of wonder for astronomers, its reddish hue distinguishing it from other stars in the Orion constellation. Can you imagine a single star overshadowing our entire solar system? To put its immense size into perspective, if Betelgeuse replaced our Sun, its outer edges would extend all the way to Jupiter. At only 10 million years old, Betelgeuse is significantly younger than our 5 billion-year-old Sunday. However, due to its enormous size, it burns through its fuel much faster, giving it a shorter life expectancy than smaller stars. Now this celestial behemoth, vast enough to contain more than 1 billion suns, is reaching the final phase of its life cycle. And when stars of this magnitude die, they don't just fade away, they erupt in a cosmic explosion so powerful that it can illuminate an entire galaxy. The last time Earth saw a supernova this close was in 1604, long before the development of modern telescopes. This event, known as the Kepler supernova, was the last supernova visible to the naked eye in our Milky Way galaxy. It remained brighter than any other star in the night sky for over a year and was even visible during the day for weeks. Ancient civilizations, including Chinese and European astronomers, documented supernovae as new stars appearing in the sky. Interestingly, remnants of the Kepler supernova in the form of an expanding debris cloud are still observable today, with powerful telescopes providing insights into the violent deaths of massive stars. Supernovae are rare events, but imagine an explosion so bright that it rivals the brilliance of a full moon, casting shadows on Earth and remaining visible in daylight. The radiation from such an event could affect satellite operations, possibly even influencing Earth's climate. Between October 2019 and mid-2023, Betelgeuse underwent an unprecedented phenomenon called the Great Dimming. Its brightness, which had remained stable for centuries, suddenly declined significantly. The change was so noticeable that even casual stargazers could see it when comparing Betelgeuse to other stars in Orion. Could this mean that we are not hundreds of years away from its supernova, but only decades or even less? By April 2023, Betelgeuse's brightness returned to normal, leading some to believe the anomaly had ended. However, in the following months, something even more unexpected happened. Betelgeuse's brightness intensified by an astounding 50%. This extreme fluctuation reignited debates among astronomers. Is Betelgeuse approaching the end of its life? Stars are not just static points of light in the sky, they are dynamic entities with life cycles and unpredictable behaviors. For most of its existence, Betelgeuse followed a regular 400-day brightness cycle. However, the Great Dimming defied all expectations, challenging our understanding of stellar behavior. One compelling hypothesis is that Betelgeuse recently ejected a massive cloud of surface material, much like a celestial volcano. Observations from the Hubble Space Telescope suggest that this ejection released 400 billion times more mass than a typical solar event, several times the mass of our Moon. This material may have formed a thick dust cloud that temporarily obscured Betelgeuse, causing it to dim. As this dust dissipated, the star's brightness returned to normal and then unexpectedly surged beyond its previous levels. Stars like Betelgeuse begin their lives by burning hydrogen in their cores. As hydrogen depletes, they switch to burning helium, forming carbon and oxygen. Over time, they continue fusing heavier elements until they reach iron. Unlike lighter elements, iron does not produce energy when fused. This causes a catastrophic collapse, leading to a supernova explosion. Research by Tohoku University in Japan suggests that Betelgeuse may already be in its carbon-burning phase, meaning its core could collapse within a few years. However, other studies such as those from Hungary's Konkoly Observatory suggest that Betelgeuse is still in an earlier helium-burning phase, meaning its supernova could still be 100,000 years away. One undeniable fact remains: Betelgeuse will become the Milky Way's next supernova, but when remains an open question. Adding to this mystery, there is an important paradox to consider. The light we see from Betelgeuse today actually left the star 650 years ago. This means that if it already exploded, the light from that explosion is still on its way to Earth. If Betelgeuse explodes, it would be a monumental event for astronomy. Scientists could study its light curve and spectra to gain new insights into stellar evolution and energy distribution. Beyond science, this event would also influence culture. Historically, major celestial events have inspired art, literature, and philosophical reflections on the impermanence of the universe. From a technological standpoint, the increased radiation levels from a supernova could impact satellite communications and navigation systems, pushing advancements in space shielding technologies. Betelgeuse's fate remains one of the greatest cosmic mysteries of our time. Whether it goes supernova in our lifetime or centuries from now, its story reminds us of the transient nature of the universe and our endless pursuit of cosmic knowledge. The next time you gaze at Orion, remember the light from Betelgeuse is a time capsule from the past, and its future is yet to unfold. Whether Betelgeuse explodes tomorrow, in a decade, or 100,000 years from now, its eventual fate is certain: a supernova that will reshape its surroundings and enrich the cosmos. But what happens after such a colossal explosion? When a massive star like Betelgeuse detonates, its core collapses, leaving behind one of two extreme celestial objects. A neutron star. If the remaining core is between 1.4 and 2.2 times the mass of the Sun, it will collapse into a neutron star, a city-sized ultra-dense remnant where matter is compressed to unimaginable densities. A teaspoon of neutron star material would weigh billions of tons. A black hole. If Betelgeuse's core is massive enough, over 2.2 times the Sun's mass, it could collapse further into a black hole, an object so dense that not even light can escape its gravitational pull. Which of these fates awaits Betelgeuse? Scientists are divided. Some predict a neutron star, while others believe Betelgeuse is massive enough to form a black hole. Either way, its death will mark the birth of a new celestial structure, altering the very fabric of space-time around it. While a supernova marks the death of a star, it also plays a vital role in the creation of new worlds. The explosion will send shockwaves rippling through space, compressing nearby gas clouds, and possibly triggering the birth of new stars. But even more importantly, supernovae are factories of the universe, forging elements heavier than iron like gold, platinum, and uranium. Without these violent stellar deaths, the essential building blocks of planets and life itself would not exist. Consider this: the iron in your blood, the calcium in your bones, and the gold in your jewelry all originated from ancient supernovae long before our solar system even formed. Betelgeuse's explosion will be another link in this cosmic cycle, scattering elements that could one day form new stars, planets, and perhaps even life. Could Betelgeuse's supernova affect Earth? One of the biggest concerns people have is whether a Betelgeuse supernova could harm Earth. The good news: scientists believe we are safe. The critical danger zone for a supernova's radiation is around 50 light-years, and at 650 light-years away, Betelgeuse is far enough that its explosion won't pose a direct threat. However, there are potential indirect effects to consider. A brilliant new light in the sky. Betelgeuse's explosion could shine as bright as a full moon, dominating the night sky for weeks or even months. Imagine looking up and seeing a new celestial object casting shadows at night. Temporary disruptions to satellites. The explosion will release high-energy radiation, X-rays, and gamma rays. While Earth's atmosphere will shield us from harm, our satellites and space missions could experience temporary disturbances. Scientific revelations: this event would be the most closely observed supernova in human history, allowing astronomers to witness stellar death in real time and refine our understanding of how stars evolve and die. Betelgeuse wouldn't be the first supernova visible from Earth. Throughout history, humans have recorded these stellar explosions, often interpreting them as omens, divine signs, or new celestial bodies.